Welcome to the solution to the Regents Physics Wave and Sound problem set, problem number 15. 15 says, sketch the result for each of the three cases shown in the diagram below when the centers of the two wave pulses exactly overlap. The first thing that you notice about these wave pulses is that they're square, or in this one down in C is rectangular. Is this because it's just convenient for drawing purposes, or is there actually such a thing as square and or rectangular waves? The answer is there is actually such a thing as square and or rectangular waves in the field of digital electronics. So if you ever take digital electronics and you see these types of waves, you'll know that there are actual waves that can be produced. Let's start with A. We have two pulses that are in phase because we have a crest that is moving to the right and a crest on the right that is moving to the left. And it wants to know what the result would be for the superposition of these two pulses when their centers are lined up on this dashed line right here. Well, what would happen is that the crests, since they're going to constructively interfere, they're in phase, so they're going to constructively interfere, and the amplitude, their amplitudes are going to combine. And since the amplitudes are the same and they're squares, that means the amplitude is going to be double of what each one is individually. And then the one that was on the right traveling to the left will continue on its way. The one that was on the left will continue to the right on its way. But when they are aligned with their centers lined up, the amplitude will double, and you see this red result here showing that superposition. B is a crest on the left moving to the right and a trough on the right moving to the left, and this crest and this trough have the same amplitude. What's going to happen when they meet up? Well, they are out of phase, so they are going to destructively interfere. That means their amplitudes are going to subtract for each other. In this particular case, they're actually going to cancel because with their amplitudes the same, subtraction would equal none. So this wave becomes, the medium becomes perfectly still or not in any vibration at that particular moment. And then just like in the previous example, this trough will continue on to the left and this crest will continue on to the right after they pass through each other. For C, we have a crest on the left traveling to the right, and we have a trough with double the amplitude of the crest on the right traveling to the left. What's going to happen in this case? Well, they are out of phase, so they're going to destructively interfere. That means their amplitudes are going to subtract. So when the crest subtracts from this trough, what's going to be left over? And what we get is a trough left over, but the trough has half the amplitude of the original trough because this crest is going to fill in half of the amplitude of the trough that was there. And then, just like in our previous two examples, this double amplitude trough will continue to the left, and this crest will continue to the right. There you have it on the superposition of these three pulses, three sets of pulses, A, B, and C. More to come as we do number 16 in class tomorrow.